Have you ever truly looked at the world around you? If you do, you'll start to see something remarkable: patterns. The honeybee's hexagonal hive isn't random. It's the most efficient way to store honey, a solution nature found through geometry. Snowflakes, too, reveal six-pointed symmetry, each unique but all following the same mathematical rules of crystallization. The nautilus shell grows in a perfect logarithmic spiral, a pattern echoed in sunflowers, ferns, and even galaxies. These aren't coincidences, they're signatures of a deeper order, a mathematical language spoken by nature. Fractal patterns appear in trees, river deltas, and even our lungs, repeating at different scales to create complexity from simple rules. The arc of a thrown ball, the rhythm of tides, the colors of a rainbow, all can be described with numbers and equations. It's as if an unseen architect used mathematics as the blueprint for reality, crafting everything from the mundane to the magnificent. Is mathematics just a tool we use to describe these patterns, or is it fundamental to the objects themselves? The bee doesn't study geometry, and the snowflake doesn't solve equations. They simply exist, embodying mathematical principles. This hints at a deeper connection between the physical world and the abstract world of mathematics. Perhaps reality itself has a mathematical soul, waiting to be understood. What if the universe isn't just described by mathematics, but is mathematics? This is the mathematical universe hypothesis. It proposes that our reality is, at its core, a mathematical structure. Imagine a computer game. Inside, everything is just code and data. The mathematical universe hypothesis suggests our universe is similar. What we perceive as physical reality is our inside view of a mathematical object. Particles, forces, even space-time, they're all features of this structure. Our scientific progress, from Newton to Einstein, is the gradual discovery of this underlying code. From our perspective, the world feels solid and real, but from the outside, it's all mathematics playing out its rules. The hypothesis asks, are we deciphering the very code of existence? Mathematics is the foundation of modern science, turning mysteries into solvable problems. Newton's equations let us predict planetary motion and discover new worlds, all from mathematical reasoning. Maxwell's equations unified electricity, magnetism, and light, predicting radio waves before we ever detected them. Every text message, every radio signal, is a physical manifestation of mathematical truth. Quantum mechanics, too, is pure math at its core. Schrödinger's equation predicts the behavior of particles we can't even see. Lasers, computers, and MRI scanners all work because we can calculate the subatomic world with math. Einstein's general relativity predicted bending light, time dilation, and an expanding universe, confirmed decades later. Even your GPS relies on these equations to work. Again and again, the equations come first. Reality follows. The universe, it seems, plays by mathematical rules at every scale. The idea of a mathematical universe began in ancient Greece. Pythagoras saw the cosmos as harmonious and ordered by numbers, discovering that musical harmony was rooted in simple ratios. This led to the bold claim, all things are numbers. The Pythagoreans believed numbers were the building blocks of reality, not just tools for counting. Plato expanded this idea, arguing that the physical world is a shadow of a higher, perfect reality, the world of forms. For Plato, these forms were mathematical. The perfect circle, the ideal triangle, existing beyond the physical. True knowledge, he said, comes from grasping these mathematical forms with reason. Above his academy's door, let no one ignorant of geometry enter here. For Plato, studying mathematics was the closest we could get to understanding reality itself. The physical world is a messy copy. The blueprint is pure and mathematical. In this philosophy, the universe doesn't just follow mathematical rules, it is an expression of a perfect mathematical reality. These ancient ideas echo in today's mathematical universe hypothesis. The question remains, is the universe truly mathematical at its core? Is mathematics discovered or invented? This debate is central to understanding our universe's relationship with numbers. Platonists argue mathematical truths are discovered, timeless, existing independently of us. Mathematicians often describe their work as uncovering a hidden landscape, not creating something new. Ramanujan, for example, felt he was revealing truths that already existed. Formalists, on the other hand, say mathematics is invented, a language of symbols and rules we created to model the world. The number 3 is just a symbol. The rules of addition are conventions we agreed upon. If mathematics is invented, why does it describe the universe so well? This is the central mystery both sides must confront. If mathematics is discovered, its structures exist independently of us. Prime numbers, for example, are universal. Any intelligent being would find the same sequence and theorems. The Mandelbrot set, generated by a simple equation, reveals infinite complexity. Discovered, not invented. Einstein trusted mathematical beauty to guide his theories, and reality confirmed his predictions, like gravitational waves. If mathematics is universal, it could be a language for communicating with extraterrestrial intelligence. We couldn't send them poetry, but we could send mathematical constants like pi or a list of primes. Any intelligent mind would recognize these patterns. Mathematics could be the ultimate Rosetta Stone for interstellar communication. This suggests logic and numbers are not a human quirk, but a fundamental feature of existence. The Platonic view. We're exploring a pre-existing mathematical landscape. The evidence is compelling. Now consider the idea that mathematics is a human invention. Our brains evolved to recognize patterns and abstract rules. Mathematics is the ultimate expression of this. We started with counting, then invented zero, negatives, and imaginary numbers to solve new problems. Think of mathematics as a language, like English, invented to communicate ideas about patterns and quantities. 2 plus 2 equals 4 is true because of definitions we created, not because it's a cosmic truth. We designed mathematics to fit the world, refining it to better model reality. Our models are like tailor-made suits, adjusted for a better fit. The effectiveness of mathematics isn't unreasonable. It's the result of centuries of crafting the perfect tool. Pi is the ratio we define between a circle's circumference and diameter. Imaginary numbers were invented to solve equations, later found useful in physics. This looks less like discovering eternal truths and more like finding new uses for clever tools. Mathematics evolves as our needs change. Perhaps its power comes from our ingenuity, not from a pre-existing realm. Regardless of whether mathematics is discovered or invented, its effectiveness in science is astonishing. Why does our abstract world of numbers align so perfectly with the physical world? Paul Dirac's equation predicted the positron, a particle never seen before, based on mathematical beauty alone. Years later, the positron was discovered, matching Dirac's prediction. The Higgs boson, too, was a mathematical necessity before it was found in reality. Time and again, equations predict phenomena before we observe them. This unreasonable effectiveness is a powerful clue. Perhaps the universe is inherently mathematical. If so, mathematics isn't just a tool, it's the fabric of reality. Or maybe our inventions work so well because they're rediscoveries of the rules we're made from. The debate continues, but the mystery deepens. So, do we live in a cosmic equation? Are we self-aware parts of a mathematical structure? We've seen mathematics woven into nature, explored the mathematical universe hypothesis, and weighed the debate over discovery versus invention. Physics offers compelling evidence. Mathematical theories predict reality with uncanny accuracy. This hints that we're uncovering the source code of the cosmos. Yet the idea that reality is a mathematical structure remains a hypothesis, a profound mystery at the edge of science and philosophy. Whether mathematics is the language, blueprint, or substance of the universe, our exploration is far from over. Every new equation is another step toward understanding our place in this elegant, mathematical cosmos. The final answer may be hidden in the next equation, waiting to be written.